Hello all. Today I am going to present a first abstract which has been accepted in COMPSAC 2024 named Distributed Threat Intelligence at Edge Devices, a large language model driven approach. The proliferation of edge devices caused a significant increase in attack surface. So one way to protect this resource conscious device is to isolate the edge devices from the network. Machine learning model can help us detect this threat, and we can further augment this process by large language model and its adaptive learning features like in-context learning. So what is threat intelligence? Threat intelligence is a process of collecting and analyzing threat information of different threat actors and its motive and different kind of attack behaviors. It helps us understand the latest threat pose and make decision based on the threat. It can also help organization to make a strong security posture against current and recent cyber threats. So to enhance threat intelligence, we propose a security framework which has 4 different components. First is lightweight machine learning model, which will detect the threat of a edge device through limited computation power. It also enable threat analysis without relying on cloud-based resources. And there is another message queue telemetry protocol. It has the PubSub pattern, which can share information between different devices from edge server to edge devices and vice versa. The edge server is the container of MQTT server and other threat detection model. It will detect the threat, and also it will share the information with other devices about the recent compromise or hack in the device. And the central LLM server contain the information of different popular threat library like open source intelligence, and it can also adapt from different new threats and vector over the time with the in-context learning feature of LLM. The system flow. The attacker first compromise a device. The machine learning model deployed on that device will detect the compromise through network traffic and system log analysis. Then it will inform the edge server through MQTT protocol. Then the edge server will analyze the thread and store the thread, and then let other edge devices broadcast the information so that they know the compromise of the device, and they will not communicate or share the further information to protect valuable data. And edge server will also share its information to central LLM server, and occasionally edge server will update its information through central LLM server, and it will become more resilient. And for this experimentation, we choose 2 Raspberry Pi and 1 Android cell phone as edge devices, and we deploy trained TensorFlow Lite model to each of the edge devices. And the other one, we also have a edge server which Core i7 64 GB RAM, which will contain MQTT and other ML model. And for LLM, we are considering OpenAPI GPT API, which will undergo training with popular threat library, and it will also enhance its intelligence through in-context learning of GPT, and will call the GPT through REST API call. If our approach is to integrate diverse other LLM and other diverse other technologies like ML, edge server, and other to tackle cybersecurity challenge of these edge devices. If it is implemented, then we can detect different cyber attacks like zero-day attack, poisoning attack, without sharing data privacy and scalability, as the ML model is deployed to every single edge devices. In future, we'll try to provide the practical demonstration of the system by implementing the system applicability in real-world deployment. And thank you.